sharing this great work. I now have the honor to present Samir Dhurde, someone I also know for a long time and who is doing an extraordinary job. And we've been discussing several times how to collaborate and to move forward this connection that we already have. Samir, thank you very much for coming here. And the presentation is about the zero shadow day, which is something that is like the first time I heard about it. Oh, what is that? That seems very interesting. So you have the opportunity to check live with Samir. What is the zero shadow day and why should we be interested in it? Samir, thank you very much for joining us, and the floor is yours.
Thank you very much, Rosa, and to all the teammates at the Global Hands-On Universe who are making this possible to share all these activities for all the people here. I could see a lot of colleagues from India as well who have just presented their special activities here. So it's been a great time till now, and I look forward to the week. So I just share my screen so that you all could see the topic that I have chosen today. So the topic is Zero Shadow Day. I am Samir Dhurde. I work in a research institute called IUCA, the Inter-University Center for Astronomy and Astrophysics in Pune, India. It's kind of to the west of the country. It's a huge country, and for a long while I've been in outreach. As Rosa just mentioned, we've been friends for a while. And in 2009, we were looking for great activities to do with the public. And at that time, we came up with this idea at IUCA. And my colleagues, who I will be naming very soon, Mr. Arvind Paranjpe, he was very instrumental in starting this very unique idea of celebrating something called the Zero Shadow Day. So before I go into that, I would just say that India being this huge country, and I can see that so many of you are participating in this conference with your talks and workshops. The Astronomical Society of India is also a major role player in outreach in India. And so if anybody wants to connect with us, I'll also give my contact at the end. I'm also the national outreach contact for the International Astronomical Union for India. So if you have any kind of contact to make with IAU or any proposals, any suggestions, any connections, please feel free to email me. Well, after that shameless plug, I'll just go into what is a Zero Shadow Day. So the shadows are very poetic. And one of my friends, Neeraj, had actually shared this beautiful saying about the shadows with me. Recently, my kid has started running around with his friends, playing something in which they have to go and catch each other. So they have to touch each other, and then the other person starts running around and trying to touch the others. You all must have played this lovely game. But as everybody knows, nowadays, you can't touch anyone. They still want to play. They have to maintain social distancing. After 5 months, they want to step outside, and they have to play a social distancing game. So I was amazed to see the other day that other than just being poetic and them getting amazed by shadows that the children see under the sun or under intense lights, they actually devised a game out of it. Now, instead of them catching each other, they let their shadows catch each other. So one of their shadows has to touch the other shadows. Amazing game, and much more complex than the regular catch game. So I can see that shadows are really wonderful instruments in play and teaching as well. But I'm sure in our project, the zero shadow or the lack of a shadow also has a big. So you can see in this picture, there's a cylinder and on this ground, and let me assure you, this picture has been taken in bright sunlight at noon, close to noon, and there's no shadow of this picture. Right? So this is an effect which can be fun to suddenly realize, and it has been useful as well in the past. So if you understand the pun, this is a well, and this is a well-known well in Syene, which was used by Eratosthenes in his method to find out that the Earth is, of course, curved, But not just that, he also used it to find the circumference of the Earth. Right? You understand and remember that experiment. So in that, he had realized that when he stood at Alexandria on a particular day, a pillar cast a shadow. But on the same day, if his friend in another place, in Sahil, looked into a well, or maybe if he looked at any other vertical object, they would have no shadows. So that is kind of one of the oldest use of a no shadow. But we still have that happening, of course, that the fact has not changed. And we still have people losing their shadows, but only in particular regions. You can see this is a very popular game in our country, India, and it's called cricket. Of course, many of you may know about this. So in this, all the players are playing in the playground, and you'll hardly see any shadows of them. Here's a picture of a lady walking by, and there's a Bullock cart, of course, something that people identify India with for some reason. And the shadows are actually not really gone, but they're at their feet, and they're very minimum. Okay. In fact, if you were to be cylindrical in shape, you would completely lose your shadow on a particular day. This day does not seem to have, cultural names at many places, but I realized that in Hawaii Islands, they actually celebrate this and they call it the Lahaina noon. The noon time on this day, you kind of have a lack of shadow. So yes, it is there in several cultures as well. So what is this and why does this happen? Well, the shadow doesn't really go away. It's just that the sun comes overhead on that particular day for you. But this doesn't happen for all places in the earth, on the surface of the earth. So we know the fact that the sun shifts its position in the sky over the year. Now, of course, this picture is slightly biased towards people from the northern hemisphere. So what we call the summer solstice is a day when the sun is towards the most northernmost position in the sky. So if you're standing here on the ground and if you're keeping a track of the sun with respect to the zenith, which is the place which is right above your head, you'll see the sun at a place which is quite north. And if you were at the equator and looking up on what is called the equinox, the vernal or the autumnal equinox, you would see the sun right overhead. If you let 3 months pass, you would see that the sun has gone towards the south and you would not have it on top of your head on the winter solstice noon. Well, just to explain it a little better, if you were, instead of looking at the sun directly, maybe you could just look at the shadow that is cast by the sun's light on the ground. So if, again, north hemisphere bias, in the summer, the sun rises in the east and the shadow is leaning more towards the south, right? In the winter, the shadow leans more towards the north. At noontime, when the shadow is the minimum, the least, it still is leaning south in the summer for us. And in the winter season, it leans towards the north. However, there are certain 2 days on which the shadow becomes minimum. And that is when the declination of the sun becomes equal to your own latitude. So you will know that the sun moves from, say, a certain position, the equinox position, towards the north, and it takes about, it goes about 23.5 degrees there, comes back and goes 23.5 degrees in this direction. And this basically causes the equinoxes and the solstices. But on a certain day, if you are within this places, if you are in a place which has a latitude equal to the any of the declinations between these range, you will experience the zero shadow day. So this is something which will be experienced by people in the tropics. Now, just to show you a close-up, it's a nice cartoon drawn by our colleagues at the Indian Mathematical Science Institute. So this is how the change happens over the year. Now, while doing this, we realized that in India, there's a big possibility of having this as an outreach event. So we have coordinated several activities in which we ask people to find out when is the exact zero shadow day for them. So basically, all they have to do is find that out and then step outside. So therefore, it's an outreach activity. So they have to go out. You can see this huge number of girls in the school standing outside at noon, trying to see when their shadow becomes the least. Now, this is, of course, an amazing activity to talk about the motion of the sun in the sky and a little bit of astronomy associated with that. But you can also explain to them the importance of observations. You can talk to them about other things in the sky. You can do any other events. You can have a poster exhibition. Anything that you want could be done with it. In fact, this gives a nice chance to geography teachers. See, for us, we see that astronomy is not a separate subject in school. It's mostly included in the physics and geography syllabus. So these teachers are sometimes looking for activities to do outside or inside, in which they can actually talk about this particular subject, astronomy, in detail. So this provides them a great chance to do that. So it's a great outreach activity, as I say. Everybody can do it. You don't need much resources. You can just go out. You can, in fact, collect all your students or your science club or your locality friends and children. And we have been reaching hundreds of thousands of students with a campaign regarding this. Here you can see some children jumping to see if they can get disconnected from their shadow and make it really zero. So yes, what do you need for these activities? You need the sun, and in the tropics, there's a lot of it, unless it's raining. But at least during one part of the year, you have clear skies, and this will happen close to local noon. So you can see a nice activity here in which somebody has written sun up here and down here and joined those two cardboard sheets. And the word sun appears in the shadow exactly when the sun comes overhead at the zero shadow time. These activities can also be included with some other observational activities. You could ask children to take notes. You can talk to them about the compass that can be made by the shadows, etc. So is it only for students? Well, this is just a picture of the IAU Executive Committee, which visited our institute and enjoyed the Zero Shadow Day moment with us on May 13th, which is the day for Pune. Of course, it's not only for students. You can see here, we have been doing a lot of activities across the country. And some of these pictures show coverage from news channels. So it's not just a educational activity. It's a public activity, and you can involve the public in large numbers. We can see volunteers from various science popularization groups. They just went out with any object they could find in their household. There's a pineapple here, some onions and beetroots and apples and bottles, anything they could find. And they just put it outside for people to see and pause for a moment and realize that this is a special moment when your shadow is almost gone. So it's a great activity, not just for students. It has great public appeal. They love looking out for their shadows, and we've also tried to make it popular over the last few years with the hashtag Zero Shadow Day. Now, India-specific activities, I know I'm kind of running out of time, but I have to focus on this, that the Public Outreach and Education Committee of the Astronomical Society of India has taken this event, this concept which came up in the IOIA, since 2017. And we've generated a lot of resources, and you can follow this link. I'll also put it in the chat. And we've done more than 60 state level training workshops with teachers being trained. And we have also reached about 300,000 to 400,000 people over these every year, from close to 2,000 to 3,000 large public events. So there is a big chance for all of us to take this up and do this. Now, I stress that this is not just for India. We've been doing this in India, and you can see India, this map is only half covered by the zero shadow region, but there's a huge range of countries, latitudes in passing through these countries, which are covered here by that band. And I think all the colleagues present in these 100 tropical countries, okay, which cover about 40% of the world's population, right? And this is a low cost and very easy activity for everyone to do. So I think we should all try to at least be aware, or make people from these countries, if you have friends in these countries, please make them aware that there's such an activity which can be easily done. And we have created web tools also to make these things easy. This is a website where you can just go there, and there's a Google map on which you can just zoom in, go to your place, close to your place, click on it, and it will tell you when your zero shadow day is. There's also an app that has now been developed by by Bullock, who's helped the Astronomical Society of India's outreach committee to make this possible. So have a look. I think we can all take this up, and it doesn't take much resources. It's free and it can be done. It can be made complex as you want. But the first thing is that you understand this, realize that there's a big potential in this activity, and try to take this up. We are here. I am Samir, and my colleagues who have been involved in this in a big way are Arvind Paranjpe, Neeraj Mohan, Ramanujam, and TV Venkateswaran. So we've been running this campaign for a long time in India. It's been very successful. And if you want more details about it, if you want to join us, if you want to participate, need resources, etc., feel free to contact us. The app is also there, so I will put down these two links in the chat. Thank you, and I'll just stop the sharing.
Thank you, Samir, very much. We're all enlightened now. I already keep thinking about having a day where we ask kids from all over the world to take pictures during the no shadow time. It would be great to have something on the map like that. But yeah, this is first food for thought. It's really a very interesting idea, something simple that all of us should be aware. And actually, those of us who lived in tropical countries, we know that exists. But it's something to think about, especially when you're talking to people that believe in the flat earth. Ask them, can you solve this problem with your flat earth? So thank you very much. It was a brilliant talk. You already can see people asking for, saying thank you, it was great. There is no specific question for you at this moment. It's just, I mean, it's good that you shared, and to know that there's so many new interesting resources connected to it. They're really very valuable and very useful.
If I have like 30 seconds, I can say that I've also presented this before to other audiences. In fact, with that, we got some collaborations, and now this app is, I think, also available in Spanish. So you could probably have a look at that. We could, as I said, the Latin American countries, the Central American countries, African countries, all the countries in the tropics, in Asia, could benefit from this.
Yeah, Gustavo, we can take this mission for the payload. Maybe we can have it in Portuguese as well.
Yes,
and with that, I thank again Samir and all the speakers from this session. And I give the floor to Gustavo, who has some announcements to make to us. So thank you, everyone, and thank you all for the great speeches that you provided, that you enlightened us with.
Thank you, Rosa. Thank you, Samir, for the fantastic presentation. I think it's really immense potential for collaboration on a global scale.